let us get started with this illustration. So here we want to compute the full price, accrued interest, and flat price. A better way to compute this is to make use of a timeline. Let us assume that today is the settlement date. The settlement date is 20th of June 2025. That's coming from here. The previous coupon payment date would be what? Since the bond matures on the 15th of October 2027, that implies that the previous coupon payment date from the settlement date would be 15th of October 2024. So from this settlement date, the next coupon payment date will be 15th of October 2025. Then the next coupon payment date after this date would be 15th of October 2026. And the final coupon payment date will be at maturity. On this date, the coupon payment will be made, and also there will be a principal repayment. The coupon rate is 3.75%. So 3.75% of par would give us the coupon. That's the coupon amount. So here at maturity, we will have 103.75. It is worth noting that we are making use of the actual date convention based on this question. So we also need to compute the present value as at this day. That's the present value of the bond as at this day. So to compute the present value of the bond, we can make use of the financial calculator. On this day, we have how many coupon payment left? We have 3 coupon payment left. So N will be 3. Also, as this date, the number of years to maturity is obviously 3 years. So N is 3. I over Y, that's 4.10. The payment, we have it as a coupon payment, and it's an annual coupon payment we are dealing with, and that will be 3.75. The future value is 100. So we can compute PV. If you compute PV with your financial calculator, I expect it to have 99.03. So let us get started with computing the full price. Since we have the value here, that's the value of the bond here, but recall that the settlement date is here. So to compute the full price, the full price of the bond will be the PV that we've just computed into brackets 1 plus R raised to power T, small letter t, divided by capital letter T. We have the PV already. The PV is this. That's 99.03, then times 1 plus the yield. This is the yield here, which is 0.041 from these dates. That's 15th of October 2024 to 20th of June 2025. How many days do we have? We've computed this in the past. We obviously have 248 days. But the capital letter T is the period between the coupon payment. Since we are using actual against actual date convention, that would be 365. So solving for this, what do I have? What I have is 101.77. That's my full price. To compute the accrued interest would be 248 divided by 365, then times the coupon payment. That's from here to here. The coupon payment is 3.75. So solving for this, you will have 2.55. But we are not done yet. We need the flat price. The flat price would be the full price, which is this, then minus the accrued interest. So solving for this, I expect it to have 99.22. Still on the same illustration, I have summarized the previous question here. On this slide, we want to compute full price, accrued interest, and flat price using our financial calculator. So let's get started. We would press second function bond. So this is second function here, then bond, then you press 20, that's 20 dot 0625, that's for the settlement date, then enter, then you press arrow down, that's the arrow pointing down. We need to enter our coupon payment, which is 3.75, then enter. This is enter here, then the arrow pointing down again, then the maturity, that's 15th dot, this is dot 1027, then enter, then arrow pointing down, the par value is 100, you need to press 100, then enter, this is enter, then the arrow pointing down twice. Now we need to change this to one periodicity. So I would press second function set to get to one periodicity because of this. And you press arrow pointing down. We need to enter the yield. That's 4.10. Then enter. Then arrow pointing down. We can now compute the flat price. Then you press arrow pointing down. You have your accrued interest. Then you press the arrow pointing down. You have your modified duration. Please, this is modified duration, not Macaulay duration.